not be able to follow the timetable. So the next talk is by Revka Amit, the proximity of sources of less and solid information in the Eastern Mediterranean.
בעברית זה יום מרגש, אני מודה שאני מתרגשת. In English, so I will try today to follow the principles that Aaron taught us as students. So one principle is always ask questions, and the term, it is well known that doesn't exist. The second thing is think out of the box and try to be creative. And the third thing is work hard, mainly in the field. And his students tried to follow it. I don't know if we succeeded, but at least we tried. So we heard about the list that Aaron worked also on, and we did during the years several studies on this topic, enigmatic topic. So just terminology, start with terminology. So the dust is a fine grain aerosol, mostly less than 10 microns. Less is coarser, so it's 20 to 60 microns. It's the coarse dust, let's say, to be simple. So first of all, you have to produce them to form the silt and clay grains to produce the dust, the coarse and the fine. And then you transport it, emission and transport it. So the long term, it's thousands of kilometers in the atmosphere, so it's the fine dust. And the short term, like spatially, so this suspension of 20 and 70 micron, so it's coarse. So the distance that the coarse fraction can travel, the transporter, is limited in comparison to the fine. So then we have the dust and less accumulation, and we have here three questions, actually. What is the mechanism of less formation in hot desert? Because you have to take a rock and produce this fine or coarse. Even the coarse fraction is a problem to produce. What is the source for the less in the Negev? Because we know the less glaciers and all this, so we don't have huge amount of fine grains. How you produce, how you got to the Negev, which was years an enigmatic question. And what is the relation between the soil formation and less and dust influx in the Eastern Mediterranean? We know, like in the 60s, Yair showed very clearly that the dust is affecting the soils, but let's see what the less is doing in this equation. So, in several studies led by Kruvy and published in several papers, we show that the less is deposit that associated with the sand dunes and the dune fields. And if you check all over the world, you always find less accumulation, downwind dune, sand fields, sand seas all over Africa. Then we move to Mongolia. We show that we start with coarse dunes, and then finding along kilometers distance, in this case 50 kilometers, so we started with 300 micron and then decrease the size to 150, and then we show that actually the glacial plateau mainly got in China, mainly got the source for the less is the filces, the moose and the tender, which is close to the less plateau. But sand dunes grains, at least in our region, is 200 microns. So how can we decrease it? Like, okay, what do we do with those sands? So, and the less is 20 to 80 microns. So we're speaking about the olean abrasion, not winnowing. And we published it in several papers, and this process was also very well experimented by walling and pullard and so on. So we're speaking about abrasion, strong winds, saltation, and abrading the sand grains. So in order to analyze all these, the results actually came out from analyzing the less on mountaintop to be sure that it's atmospherically deposit. So we found several sequences on top of the mountain, which wasn't so trivial because it's an aeolian deposit and it can come and go, but still we found them, and in analyzing them, so we found first that we're speaking about bimodal distribution. So we have the fine fraction 4 to 8 and the coarse fraction 30 to 80, and the coarse fraction is mostly quartz. And you see the quartz here until the SEM, and it's chopped and it's angular. So the question is, the negative is the actually carbonate terrain. How can we get all this quartz amount? The glacial soil profile in this northern Negev, we're speaking about 100 millimeter here, about 150, not that extremely. And always we speak about the less as a desert deposit, but in the real desert, like south to Ramon crater and to Holodet, no less at all. So again, in our region in Israel, so the less deposit downwind the negative sand dunes. So opening the pits, sometimes we need a backhoe for that. So thick soils and paleo soils, beam or 3 model, but the very fine, actually it's a beam model. Again, 30 to 80 and 4 to 8 micron. We went to the fringe, so we have here the sand coming from the Nile, entering into the Negev, the northern Negev. This is the boundary of the less area, and here we went to the fringe of the less, the inner coastal plain, Tzura, Lachish, so on. So we found a decrease in the grain size. It's 35 to 45 micron, and a small peak of the very fine. Again, thick soil, glacial soil. In this case, the age is 33 Ka. And you see the landscape, it's chalky terrain. At the top of these hills, we found a thick glacial soil. In the soil map, it's a brown soil or a bromosoil, but bromosoil always deposited by, it's a fluvial. Here, no fluvial, it's at the top of the mountain. So to summarize this story, the sand that came into the Negev is the Nile Delta is the source for that. The sands that compose the sand field of the Negev is post the age of the carbonate siliciclastic unit underneath the sediments here, and the date is 335 Ka to 23 Ka by Tal 2002. So, and the sands themselves, the time span is 190 to 20 Ka, and we see the transgressive penetration or distribution of the sand into the Negev. So we are speaking about the proximal less deposition. This is the less of the Negev. In the south, we don't find any less. So the ages of the mountain top less, it's a primary less, is about 180 Ka. The age of the less in the channels is later, it's about 70, 80 Ka. So the only source for the quartz-rich part material of the quartz silt formation in carbonate terrain in the Negev is the Sinai Negev sand field. Okay, so we went to see what's going on in the very north. We showed you what's going on in the coastal plain, and then we moved to the upper Galilee, to the mountain top. We know that it's the terra rossa, mostly composed of dust. The unimodal, mainly 3 to 7 micron more. And if we compare to the less, very thick soil, bimodal, coarser, so we have two different environments. But in Israel, because we have the proximal and the distal, the amount of the unknowns is high, so we decided to move. So we left with a very interesting question: can less influx change the soil productivity of the Mediterranean environment? We saw that in the Upper Galilee, very thin, nothing almost, in the south, thick soils and so on. So what happened prior? Because we know that the less, it's not like Chinese, it's million years ago. We know it's only 180, it's very young. So we moved to Jerusalem area, to the Judean mountaintop, and in Emit a work which is now under press in QSR with Google and mainly dealing with the prehistory. But for us, it was a treasure. We found this sequence. The lower part is 243 Ka, and we see only the fine peak. It's unimodal in 3 to 5 micron, not much dust or less or fine or coarse. And then when we go to the younger unit, it's again a bimodal with 30 to 45, like in the inner coastal plain. So we see the signal of the less in the Judean mountaintop. But it wasn't enough for us. So we moved to an environment which has no sand dunes, nothing. The terrain is carbonic, and we moved to Crete. It's an island. It's get the Sahara dust, fine dust. Here it is collecting the fine dust, and you see the bare mountains. So we went along from the central part of the island to the east, and the results were unimodal 5 to 8, pi independently 92, find the same result. So no less the soil is shallow and the terrain is bare and no soils actually. So to summarize, this graph is showing the particle size and the location, the latitudinal to the north. So the less in the Negev, the Shiva, so we have the bimodal and the coarse and the fine. Then we move to the Jerusalem, to the Judean mountains. Still we can follow these two peaks, and then the Upper Galilee, the Crete, very similar. So here we are speaking only on the long distance dust, the Saharan dust. So here in this map you can see the clay which increased, clay particles increase northward to 60, 50, and very low amount. It's relatively, of course, to the coastal fraction. So in Beersheba area, we're speaking only on 20%, and the fine sand is increasing southward. So less than 10 and less toward the north, and higher values toward the south. Another thing which is important, Judean mountains, and we know Judean mountains to the south, like Hebron mountains and so on, the southern backbone of the mountains in Israel has those terraces. And it's years, like thousands of years, cultivated terraces with fruit-free trees and vineyards and so on. In the Galilee, no terraces, almost no terraces. And we know that the amount of precipitation is higher here, and it should be more productive than in the south. So this years bothered the archaeologists, and Golom and Kedar in 71 said the system of terraces in the Galilee is inferior to other types of cultivation and to the kind of terracing found in Judean hills. The reason for this inferior quality of terracing in the Galilee may be explained by the fact that the inhabitants were small tenant farmers who lack resources of construction of elaborated terrace work. It's a nice idea, but we think it doesn't work. So what we propose here, so you see the map. In the less area, we're speaking about 100 millimeter to 200 millimeter a year. In the north, we're speaking, we can reach more than 1,000 sometimes. So the coarse fraction controls dust mass accumulation rate, and in turn determine the thickness and the degree of soil development around Mediterranean. So actually, good soils are related to coarse dust deposition, and which result in thick soil profiles. Contrary to precipitation amount and the rock weathering rates are not the main factors in the process of soil formation in Mediterranean carbonate terrain. We know that the dissolution of the carbonate terrain is very high, and there are many works. The last work by Rib would show it very clearly, and the residuals are almost nothing, 1 to 2%, even Aaron measured that. So accretion rates of incoming coarse dust are mattering. So we need, in order to form thick soils with high productivity, we need this less. We need this coarse dust, local coarse dust. So now I will leave you with thinking about the next question. We're speaking about the Promised Land. We're speaking about the Arden Maadi. We speak about the land of milk and honey. And here you see the Lachish relief with the vineyards, and well known, and we know today that it's one of the areas that cultivated and modern in the north. We know that the new immigrants moved to the north to make agriculture, and they couldn't do it on the border of Lebanon, and nobody understood why they couldn't do agriculture there. So, with no soil, maybe no promised land, maybe no problem. So, I will leave you with that.